Welcome and good morning, everyone. I want to welcome you today to today's webinar that we're going to put on. The name of the webinar is Beryllium and OSHA Compliance. My name is Dan Larson. I am a safety and health consultant with the Indiana University of Pennsylvania, Pennsylvania OSHA Consultation Program. And we're going to be doing this webinar today to kind of help you understand beryllium and OSHA compliance. Again, the standard we're going to be talking about when we get to the OSHA compliance portion of the presentation is 29 CFR 1910.1024. If you have any questions during this presentation, you're welcome to submit them through the chat feature, and we'll certainly get back to you with an answer. If you can also contact me at the end of the presentation, you'll have my contact information. That's my email or phone number, and you're welcome to submit questions, ask things there as well at the end of the with that information. So we're going to do I want to do a short introduction here on beryllium, the background, some health hazard information for you. Before I go on, I want to just mention about the Susan B. Harwood training grants. OSHA awards grants to nonprofit organizations on a competitive basis, and they do that through the Susan Harwood training grant program. The one I want to talk to you today about is the Beryllium training grant that was given to the National Jewish Health Organization. And the National Jewish Health Organization developed the training program through the Susan B. Harwood training grants. And it talks about the health hazards of beryllium, the training, high exposures, jobs, protective measures. And so I'm going to be referring to the slides developed during that presentation during some of my introduction here. So beryllium, what are we trying to do here? We're trying to prevent chronic beryllium disease through exposure, recognition, and control. And again, these introductory slides were developed by the National Jewish Health Organization. So beryllium, what kind of forms are there? You can have different forms of beryllium, of course. There's just the pure metal form. There's ceramic alloys are the ones that you're going to most commonly see in industries such as beryllium copper and aluminum beryllium. Beryllium is also a contaminant in bauxite, which is like sedimentary rock, as well as alumina and recycled metals. You can see some pictures there on the right. The little ball is pure beryllium. The wrench material is an alloy material, beryllium copper, and then a ceramic material on the top there. The reason beryllium is so useful is it has some very good properties. It's 3 times lighter than aluminum. It's stiffer than steel. It conducts heat very well. It's dimensionally stable, and it's transparent to X-rays and reflects neutrons. And that's one reason it's used in the nuclear industry, is because it's transparent to X-rays and its ability to reflect neutrons. There are uses, of course, for beryllium. Here are some of the more common ones in the airplane and space industries. Nuclear reactors, your computers, your phones, your iPhones, these all have small amounts of metals in them. Some of them are beryllium. In the automobile industry, it's used. It's also used occasionally for dental oil alloys. And then beryllium is actually a contaminant in the aluminum smelting process, and you can find it in metal recycling. So there are some beryllium uses that we have here. From here, I want to jump into the health effects of beryllium. The main health effects of beryllium come from the inhalation of the beryllium dust. With beryllium, there are really 2 routes of exposure. You can get exposure when you inhale the beryllium particles that will then enter your lungs, and they're so small, they filter down into the gas exchange regions of your lung, the alveoli. And that's where a lot of the problems occur from the beryllium dust. There's also skin exposure, where you can have exposure from your skin be it even from a closed skin or an open cut. That is definitely a route of exposure because it can cause sensitization. So here are some of the lung effects health effects from lungs. There's acute beryllium disease, lung cancer. Beryllium is considered an A1 carcinogen. But the two that we're going to talk about most today are beryllium sensitization and chronic beryllium disease. And of course, skin, if you work with beryllium, there are skin effects, and you can also have sensitization there. If you work with beryllium, and there are skin effects, as I've mentioned. For instance, if you have an open cut or wound and beryllium particles get in that open cut, it's going to cause a slow wound healing. The beryllium particles can also get under your skins and cause nodules, little raised parts of your skin. You can have a rash, or you can have beryllium sensitization. And this can occur from broken skins and cuts, rashes, and even unbroken skin can be unbroken skin may not be a barrier. The ACGIH actually lists some forms of beryllium as a skin hazard. So the cutaneous route of exposure is pretty significant. So this is one reason, of course, why broken skin and cuts need to be covered, and really any skin needs to be covered when you're working with beryllium to reduce the risk of beryllium sensitization. As we go on with lung effects, there's a disease, acute beryllium disease. In the 1930s and 40s, we used beryllium, for instance, in fluorescent bulb plants. And there was really, in these areas, there was quite a high exposure. As a matter of fact, it was measured at 50 to 1,000 micrograms per cubic meter of air. So if you are in a situation where you have extremely high amounts of beryllium, maybe it's an emergency or something like that, you can actually have acute beryllium disease. It is similar to pneumonia. 5 to 10% of those with this disease have died. However, many of those have recovered in less than a year. Again, acute beryllium disease is very uncommon in these current times because we don't have jobs where the exposure is nearly as high. Lung effects. Let's talk some more about beryllium sensitization and chronic beryllium disease. Beryllium sensitization occurs because the particles of beryllium, maybe you inhale them, you get them into your lungs, or your skin, an allergic reaction occurs. And when this allergic reaction occurs, your body begins to create more immune cells, and that's called sensitization. Now, there are no symptoms for sensitization. You really don't, you don't feel differently once you're sensitized. So you may not even know you have it when you have a beryllium sensitization. And the only way to find that out is through a beryllium test, what they call a BELPT. And workers with beryllium sensitization, the risk is that they can now go on to develop chronic beryllium disease. And chronic beryllium disease is can be a very bad disease. It's inflammation, but it really causes the scarring of the lungs, fibrosis. You have granulomas that occur in your lungs. And so it is it's an illness, it's a disease that is a big concern in the beryllium industry. However, it is good to know that most exposed workers will not be sensitized or develop chronic beryllium disease. And low levels of exposure decrease, but do not necessarily eliminate the risk of beryllium sensitization or chronic beryllium disease. So how do you know? Are you at risk for beryllium sensitization and chronic beryllium disease? Well, the answer is it really depends. It depends on your genetics. It depends on exposure conditions. And as you can see from that little drawing, that represents a facility maybe with beryllium workers. Many of them have no reaction or no sensitization or no disease at all. But again, based on maybe your genetics or what the exposures at your facility, what type of beryllium you're using, you may become sensitized. And then if you do become sensitized, then you can develop chronic beryllium disease. So this slide is a demonstration of what occurs during beryllium sensitization. First of all, you inhale the particles, of course, into your lungs or on your skin. They come into contact with immune cells, and the top part of the slide there shows that how the beryllium, if it contacts the immune cells and there's no response, the immune cells really don't change. They don't multiply. But under the abnormal response, where beryllium sensitization occurs, the immune cells are come in contact with the beryllium particles, and then you have a condition where sensitization occurs, and then the immune cells multiply. And of course, there can be inflammation and different things that occur because of that. And that is when you become beryllium sensitized, when there is a reaction with the immune cell and the beryllium and changes occur. And again, exposure, that's determined by really your exposures and your genetics. This slide here demonstrates chronic beryllium disease. You can see, again, the particles are inhaled and they go into the lungs. They're very small particles, obviously less than 10 microns, very small diameters, and they get down into the gas exchange regions of your lungs. There's a slide there with a normal picture of a lung, and then a slide with a picture of somebody with chronic beryllium disease. And you can see the granulomas are forming there, and that causes limits you the amount of oxygen that can pass into your blood. And that's really where chronic beryllium disease becomes a problem, because it restricts your ability to have the oxygen pass from your lungs into your bloodstream. What are symptoms of chronic beryllium disease? No symptoms. There's really no symptoms initially. You may have the disease and not even know it, but over time it will worsen. You'll maybe develop a cough, shortness of breath, sweating at night, feeling tired all the time, and then maybe the shortness of breath will even become more severe. And this is the reason when you have CBD, it can be mistaken for other lung diseases. And really, the only way to know if you have chronic beryllium disease is to have some blood work done and the BELPT test. If you have symptoms, of course, if you have lung symptoms, you need to be sure and tell your doctor that, hey, you are exposed to beryllium. How do they treat chronic beryllium disease? Well, there is no cure, but the symptoms can be treated. If you have no symptoms, of course, you're going to have no treatment. If you have mild symptoms, they're going to move on with some type of inhalers or inhaled medication. As symptoms begin to worsen, your medication is going to increase. For instance, they're going to start maybe using prednisone or steroids, or even other more stronger medications. And eventually, you can even, if the disease becomes severe, you can move on to actually require the use of oxygen. So how do we test for beryllium sensitization and chronic beryllium disease? Well, the first thing that has to be done through medical surveillance is a blood test. That's called the BELPT, or beryllium lymphocyte proliferation test. And during that test, immune cells multiply when they're exposed to beryllium. And that's a very important, that's part of like the OSHA compliance medical surveillance program. And so you actually have to have 2 tests positive to really be diagnosed with beryllium sensitization or chronic beryllium disease. This is a demonstration. This slide here just shows what they do with the beryllium LPT test. You have your blood cells. They introduce beryllium. They take a blood sample, of course. They introduce beryllium to the blood sample, and if you have a normal reaction, those blood cells don't change. But if you have an abnormal reaction, you can see where the immune cells multiply. And if that occurs, again, they diagnose you with beryllium sensitization or chronic beryllium disease. Along with the medical surveillance, the blood work that has to be done, you also have to have a very thorough medical evaluation where they're going to take a history of what you've done, maybe your work or what you do at home. And they're also going to do probably pulmonary function tests to evaluate your breathing capabilities, exercise tolerance tests. They'll do CAT scans, X-rays, and the important one here is the bronchoscopy, where they'll actually take a tool, go down into your lungs, maybe snip a few of the immune cells out, and they'll bring those out and test them for beryllium sensitization with the BELPT test. And they also may do a biopsy of your lung tissue, and they're looking for granulomas or an abnormal collection of cells. When can you get beryllium sensitization or have chronic beryllium disease? Well, it can occur soon, even within 3 months of work. It can occur after many years of work. Sometimes it doesn't even occur until you have no more exposure, because the reason that is because beryllium stays in your lungs. And again, you can even have a normal blood test, BELPT test, but that's why you have to be vigilant and continue to monitor. And if you continue to have chronic CBD symptoms, continue to be checked. So the next step we want to talk about here a little bit is, okay, you work with beryllium. Let's talk about the exposure recognition and control in occupational settings. So how can you be exposed to beryllium at work? Well, again, beryllium are particles. It's a metal. It's produced by work processes, and these particles, can be blown from work surfaces, maybe clothing, maybe from the floor. Again, these are very minute particles, so it's very easy for them to get disturbed and blown around in the workshop. Maybe you have exposure from particles at a nearby work process. Maybe you don't work with beryllium, but maybe they come from a nearby process. And of course, you can have skin contact exposure as well from beryllium parts or contaminated surfaces, floors, horizontal surfaces, tables, and things like that. And here you have a demonstration of the particles that just kind of showing how the particles can be inhaled and you can be exposed. How do you know if you're exposed at work? Well, if beryllium is used in your workplace, you may be exposed. Some of the job titles that can show exposure are machinists, production workers, maintenance workers, cleaning personnel, laboratory personnel, shipping and receiving. And it's even possible if the beryllium is not well controlled, that you can have dust from the shops getting out into offices and exposing office workers or security guards. And unfortunately, even if the dust is not properly controlled, you can be taken home to family members. So if you have beryllium in an occupational setting, how do you measure how much beryllium is there? And of course, in that case, you need to retain the services of an industrial hygienist. An industrial hygienist is going to do sampling. These samples could be two different types of samples. There are air samples, which measure the amount of beryllium in the air, and that is used to estimate, how much a worker is exposed. What is his or her exposure level? There's different types of air samples to consider when you're, as an industrial hygienist. You have personal samples that you're going to use to evaluate employee exposure to beryllium, and maybe you're going to also include some area samples, or you want to see if engineering controls are effective, the beryllium work areas are properly established. So those will be area samples. So air samples are used to evaluate what is the airborne concentration of beryllium. Secondly, you have surface or wipe samples. These might be taken from surfaces to determine, are you getting beryllium in your lunchroom, or are you getting beryllium outside your beryllium work areas? And so they can also be an effective tool. Here is a slide. If you see the picture there, you can see somebody with an actual air sampling pump on them, where you have the pump on their belt, you have the tie gun tubing, then going up over their shoulder, and then that cassette is placed in the worker breathing zone for their work shift. This is how OSHA requires sampling to be done. That cassette in the worker's breathing zone, after the shift is over, the industrial hygienist will take that, put it on a chain of custody, document everything properly, and send that out off to a lab for analysis. So what about the chemical form of beryllium matter? Well, there's different forms. We talked about those earlier. There's pure beryllium metal, metal alloys, beryllium silicates, beryllium salts. The research doesn't indicate that there's, as long as the exposures are the same, that there's a lot of difference in risk between the pure beryllium metal and the beryllium alloys. It seems that there's again, if exposure is the same, it seems like there's a lower risk if you're exposed to beryllium from soil and rocks, maybe like coal ash, things like that. It seems like there's a lower risk there. And it seems like there may be a higher risk. There's certainly information that there's a higher risk if you're using beryllium ceramic or beryllium oxide. This is very important. I just want to mention again about particle size. You can see there, it have a blue dot representing the average human hair, which is 100, estimated that 100 microns in size and diameter. Again, beryllium particles are considered to be respirable. They're less than 10 microns. If you have many industrial processes, especially those such as lapping and machining, can generate very small particles. And these can be even, in the 1 micron range. So if you have a very small particle, if you look at the bottom there, you can see small particles can spread throughout the building and has settling time in still air. If you have a particle that's 100 microns, which is like a human hair, it's going to settle out in 8 seconds. However, when you get smaller, there you have a 10 micron particle, takes about 10 minutes to settle out. But if you get down into the very low respirable range, 1 micron, that particle may not settle out in still air for 10 to 15 days. So you can see that you have beryllium particles that are generated. And again, the particles may not necessarily just go right to the ground. They can be in the air, they can get moved around through fans, through ventilation systems. So it's just real important that you understand that the beryllium particle size is very small. Is skin exposure important? Well, certainly it is. You want to cover the skin to reduce the risk of beryllium sensitization. Beryllium can obviously enter damaged or cut skin. It can be dissolved in sweat and may get passed through the skin. Again, ACGIH considers beryllium to be a skin hazard. Here we have some sampling that was done, some beryllium hand wipe samples, and you can just see that the assembly debris area was 270 micrograms, the machinist 220, maintenance 74, and even in the administration area at this facility that was evaluated, there was a little bit of beryllium on their hands. And even after hand washing, there was still beryllium present on the hand. So you can see, again, it's very important that you cover the skin to reduce the risk of beryllium sensitization. Well, how about take-home exposures? It's important to realize that beryllium contamination, beryllium particles can be in your clothes, can be in your work clothes, can be in your shoes. Here's an example of some samples that were taken from a vehicle of a beryllium worker. Steering wheel 5.3 micrograms, driver's floor 76.8, driver's armrest 39.7. So again, it's important that you change clothes, change shoes, shower, wash, whatever is necessary to prevent take-home exposure to yourself and your family. So we want to move along now, and I want to, we've talked about the health effects and measuring exposure, where exposures occur. I want to talk now about how you can control exposures in the workplace. And we're going to do that through a variety of methods, a variety of controls, and they're listed there: engineering controls, work practice controls, administrative controls, personal protective equipment, and medical surveillance. So let's talk about engineering controls. These are obviously the best controls to use because they remove the contaminant, the beryllium, if you will, at the source and take it away from the worker so that beryllium doesn't get in the worker's breathing zone. There is no inhalation, or it doesn't get on their skin. The best ones you can use are the wet methods. Wet methods is a great control. Ventilation, local exhaust ventilation. Take that contaminant, remove it from the worker's breathing zone, carry it out of the area. Enclosures, or even facility design. You're going to use hard cleanable surfaces. You're going to separate your beryllium for your non-beryllium processes, and you're going to have separate ventilation systems for your beryllium versus your other things. So engineering controls are great. They're the best ones to use. Here's an example of a wet method and local exhaust ventilation. You can see that the process there is enclosed, that there's a fluid, maybe oil being used. And then there's the blue local exhaust ventilation is also being used to ensure that the beryllium contamination is moved out of the area. Here's an example of an enclosure with local exhaust ventilation. Obviously, you can see the plexiglass, the process is enclosed inside that cabinet. And then not only is it enclosed, but in the back of that cabinet is local exhaust ventilation to remove the particles. Well, okay, so what about work practice controls? These are very important as well, and they can very much help with your exposure, controlling exposure in the workplace. You want to use, obviously, the proper use of engineering controls that we already talked about. You want to label all your beryllium materials. Use HEPA vacuums, industrial HEPA vacuums if you're cleaning up dust or particles that contain beryllium. You want to make sure you use a HEPA filter on your vacuums. Do not use a shop vac, because remember, the beryllium particles are very small. It's just going to pull it in and blow it out the back if you use a shop vac type of equipment. You want to have a HEPA filter on any vacuum. Hey, don't use compressed air for cleaning, because what does that do? That just blows it into the air and creates airborne exposure for yourself and others. Wet wipe and mopping. You want to ensure you do that. Do not dry sweep. Of course, do not eat, drink, or eat or drink in beryllium contaminated areas. And training is certainly critical for success, because employees, workers, they need to know what they're working with. They need to be trained on what are the proper work practice controls, what's required of them, what are the proper engineering controls, what's required of them. And then there's also administrative controls. What can the company do, or what can be done administratively to control exposure to beryllium? Well, you can restrict entry to beryllium areas. We're going to talk about regulated areas and beryllium areas. You can limit access to these areas, so there's the chance of people who don't need to be in those areas aren't in those areas. You want to let contractors know that certain areas contain beryllium. And you can also limit the spread of beryllium through the use of work uniforms, shoe covers, sticky mats, change areas, clean break areas. Again, changing clothes, changing shoes, showering is a very important way to prevent take-home exposure. And then after all the controls are put in place, the engineering controls, the administrative controls, the work practices controls, you may still need personal protective equipment, and that can be to protect your skin or to protect from inhaling the beryllium particles. If you're going to need skin protection, things are like a long sleeve work uniform, gloves, things to protect open skin, uncovered skin, so that beryllium doesn't get on that skin, doesn't have exposure, and you don't have sensitization. If you have to protect your have to have personal protective equipment for inhalation, obviously you're going to wear a respirator. There's a picture of a HEPA filter on a respirator. Respirators are great, but keep in mind all PP has to be used effectively and properly. It has to be properly trained. Obviously you can't, if you have a negative pressure tight fitting respirator, you can't have a beard. You have to use it when it's required, and there's some requirements such as fit testing, medical clearance, and training that you have to go through. And then lastly, medical surveillance. It's important that your company has a medical surveillance program. Medical surveillance is going to help you determine that if you have engineering controls in place, work practice controls in place, administrative controls in place, medical surveillance is going to help you understand, are these controls that we have in place working? Okay. And, do you have workers with beryllium sensitivity, and maybe you need to take additional action? Of course, why do medical surveillance? To determine if your exposure controls are working, and to use as a safety net for exposure control. And of course, it helps confirm that your exposure controls are working, as I just mentioned. Okay, I want to jump now to OSHA compliance. That's the introductory section where we talked about health hazards and controls and what is beryllium. Now I want to talk to you more about OSHA compliance. OSHA compliance is, there's a standard for beryllium. It's 1910.1024. The standard timeline prior to 2017, the PEL for beryllium was really considered too high, and it did not really adequately protect employees. So starting in 2017, OSHA issued a final rule. The initial rule, there was some confusion, and they got a lot of pushback from industry. Over the next couple of years, OSHA established some clarifying amendments and some additional things that helped make the standard better for everyone. And in 2020, the final rule became effective, and that's the rule that we use now. Again, it's 29 CFR 1910.1024. And that's the rule that we are now using, became effective September 14th, 2020. So how do you know if this rule, the OSHA rule 1910.1024, applies to you? Well, it does not apply if your workplace, if you're using or you're processing materials that are less than 1.1% beryllium by weight, and it's important that you understand, and where you have objective data demonstrating that your employee exposure to beryllium will remain below the action level as an 8-hour time-weighted average under any foreseeable conditions. So you must meet both criteria. You must be using a process that is working with less than 0.1% beryllium, and you must have objective data showing that your employee exposures are below the action level, and that is under any foreseeable conditions. So, maybe you have to take into consideration your ventilation. What if your local exhaust ventilation stops? So it's got to meet those two criteria to be left out of the standard. So if either one of those is true, the standard applies to you. OSHA has established some exposure limits, action levels, permissible exposure limits, and short-term limits. The action level for beryllium as an 8-hour time-weighted average is 0.1 micrograms per cubic meter. The permissible exposure limit is an 8-hour time-weighted average is greater than 0.2 micrograms per cubic meter. And the short-term exposure limit which is a 15-minute time-weighted average exposure, as 2.0 is greater than 2.0 micrograms per cubic meter. So OSHA has set the standard. They've established the permissible exposure limit, the action level, this STEL limits. So now what do you have to do as an employer? An employer has to assess the airborne exposure of their employees who have exposure to beryllium. And this assessment can be based on a combination of air monitoring data or objective data, which is sufficiently accurate to characterize exposure. The information you has to be representative. You have to be able to clearly say, this is what our employees are exposed to. in this case, under exposure assessment. So you evaluate your employee exposures and you compare them to the OSHA level, the OSHA action level, the OSHA PEL, the OSHA STEL. And when you're doing the air sampling or the air monitoring, if you have an industrial hygienist, really the results that you want to have are breathing zone air samples. And again, that sampling has to be representative. If you have multiple employees working in the same area and that they do the same task, you want to sample the employee expected to have the highest exposure. And obviously, if you have work changes that occur, maybe a production change or an operation change, that's going to make the employee exposures different. You have to reassess and do another exposure assessment to determine what your employee exposures are. Once you have that information, you know what your employee exposures are. Then after what's called the initial monitoring, if you have employee exposure that is below the action level and at or below the STEL, no additional monitoring is required unless operations change. If you have employee exposures that are at or above the action level, but at or below the PEL, you need to repeat air monitoring every 6 months. If you have employees exposures that are above the PEL or STEL, you need to repeat air monitoring every 3 months. And this repeat air monitoring is just to ensure that you know what the exposures are the employees continuing to wear the proper type of personal protective equipment, such as respiratory protection. If you make workplace changes and you get sampling results that show employee exposures are below the action level, you can discontinue your exposure monitoring program if you have 2 consecutive measurements taken more than 7 days apart, which are below the STEL and the action level. And you must notify employees of what the results were. Anytime you do the sampling assessments, you must notify employees within 15 working days of completion. So Beryllium work areas and regulated areas. Well, the first thing you're going to need to do is establish a Beryllium work area. And the definition of a Beryllium work area means that you have a process that you're working with, and the process involves at least 0.1% beryllium by weight. And that operation is listed in Appendix A of the OSHA standard. Or if you have employee exposures, which can be expected to be or reasonably expected to be exposed to beryllium at or above the action level. So if either of those two situations is the case, you have to establish beryllium work areas, and then there's many certain things that you have to do because you have a beryllium work area, and we'll go over those. You may also need to establish a regulated area. This is an area where employees are or can reasonably be expected to be exposed to beryllium levels above the PEL or STEL. Or you may be able to have to establish a regulated area if you have like an emergency or a maintenance task that's going to generate exposures. With beryllium work areas and regulated areas, you're going to want to identify these areas with signs. You're going to want to establish boundaries and limit access to only authorized persons. And you're going to want to provide the necessary PPE, and maybe that may even include respirators. Methods of compliance. So now we're going to move through the OSHA standards some more here. First of all, they have different methods of compliance. First thing you have to do is you have to establish a written exposure control plan. Now, this is a written document that you keep on site, must be made available to employees. And some of the things that have to be included in this is some but not all, is, for instance, a list of operations and job titles where your airborne or dermal exposure occurs, a list of operations job title where you have exposure at or above the action level, PEL or STEL. You have to list in this exposure control plan the procedures for how you're going to keep surfaces with beryllium as clean as practicable. And you're going to have to list procedures for handling beryllium contaminated PPE or clothing. The exposure control plan has to be reviewed annually and has to be updated by a competent person. And the copy of the, as I said, the copy of the exposure control plan has to be made available to employees. And the employer must utilize engineering work practice controls to reduce and maintain exposure to below the PEL and the STEL as feasible as possible. And you cannot rotate employees to different jobs to achieve a compliance with PELs. So those are some of your methods of compliance. Respirators are going to be required if you work in areas where exposure exceeds the PEL or as short-term exposure limit, STEL. The employer must provide the respirator at no cost to employees. If in areas where respiratory protection is required, if an employee requests that a powered air purifying respirator be provided, the employer must provide it in areas where respiratory protection is required. Of course, if you are using respiratory protection in the workplace, there are other standards that are going to apply. For instance, you're going to have to comply with 1910.134, the respiratory protection program. That involves things such as selection. You make sure you have the right respirator in use, training, fit testing for workers. If you wear a respirator, if you wear a negative pressure tight fitting respirator, you're going to need to be fit tested, of course. And then, of course, if you wear a respirator of any kind, you require a respirator. You have to have a medical evaluation to be sure that you're cleared to wear that respirator. Of course, respiratory protection and personal protective equipment. The employer must provide PPE at no cost to the employees. Beryllium contaminated PPE and clothing. This is important to understand. So you're dealing with clothing and you're in a beryllium work area and you have clothing and personal protective equipment. First of all, you have to remove that at the end of each work shift. It has to be stored separately from street clothes. It cannot be removed from the workplace. And it has to be stored and transported in sealed bags or other closed containers and labeled. If you're using an outside service such as an outside laundry service, they have to be notified that the clothing may be contaminated with beryllium. And of course, again, the containers have to be labeled. And you may not blow or shake off the personal protective equipment or clothing to remove the beryllium contaminated dust or debris. Well, how about hygiene areas, practices, and housekeeping? If you have for an employee who's in a beryllium work area or expected to have dermal contact, you have to have readily accessible washing facilities that must be provided. You have to wash exposed skin at the end of the process, activity, or shift, and prior to eating, smoking, drinking, chewing gum, chewing tobacco, or applying cosmetics. The hygiene areas must be provided. Employees must be provided a designated change room if they're required to use personal protective equipment or other equipment. Showers can actually be required if employee exposures exceed the PEL or STEL and the employee's hair or body parts other than hand, neck, and face area are expected to be contaminated with beryllium. So there are certain cases where even showers are required to be provided. And an employee may not enter eating or drinking area wearing beryllium contaminated PPE or clothing. All areas, including eating and drinking areas, must be maintained as clean as practicable from surface beryllium contamination. Section K and L of the standard, we talk about medical surveillance. Now, medical surveillance is you have the industrial hygiene portion where you come in and do air monitoring to evaluate employee exposure. And then you have the medical side where if employees are exposed to beryllium at or above the action level for 30 or more days a year, they have to be entered into a medical surveillance program. And again, this is going to be where they do tests like the BELPT test. They're going to get the medical exams where they're going to check their lungs. And it has to be provided for employees if you're exposed to beryllium at or above the action level for 30 days or more per year. It also must be provided for employees if these employees are showing signs or symptoms of chronic beryllium disease or other beryllium related health effects. Medical surveillance must be provided if employees are exposed to beryllium, maybe during an emergency task. And the medical exam that is given to these employees as part of the medical surveillance program. The medical exam must be provided within 30 days of hire or assignment and every 2 years thereafter and at termination of employment. Of course, the medical surveillance program, the medical exams, they all have to be performed under the direct supervision of a licensed physician. And an employee is actually eligible for medical removal from a job, if they're working in a job where exposure is above the action level and removal is recommended by a medical professional. So the next thing let's talk about is communication of hazards. Of course, this is the hazard communication program. You have to comply with the HAZCOM standard 1910.1200. You have to communicate hazards with employees. In the case of beryllium, the minimum things you must address are cancer, lung effects, and we talked about these: chronic beryllium disease, acute beryllium disease, beryllium sensitization, skin, eye, and respiratory tract irritation. You must provide employees with access to labels, safety data sheets on beryllium. You must provide and display warning signs at each approach to a regulated area. Beryllium must be included in your hazard communication training program that you use when you initially hire people or introduce new chemicals into the area. And beryllium training is actually required initially upon hire and annually thereafter. And as an employer, you have to provide a copy of the hazard communication written program, the beryllium exposure control plan, and a copy of the actual OSHA standard 1910.1024 must be readily available to employees. And then last thing, record keeping. You have to keep this information for quite a long period of time. Any air monitoring data or objective data that you may have has to be kept for 30 years. This can be seen in the OSHA standard 1910.1020. And then medical records. You must keep the medical records for employees for employment plus 30 years. So that sums up as a quick summary of the OSHA compliance information 1910.1024. It's not a long standard, and you can look at it yourself if you'd like, but it gives you kind of a summary of what are the basic things that are found in that standard. The last thing I want to talk about briefly here is there's actually an example I want to show of an OSHA inspection that was performed with beryllium. Now, it was performed a few years ago prior to what the current standard is now, but I think it's a useful tool that you can see what happens during an OSHA inspection, why an OSHA inspection occurs. So this is an example of beryllium overexposure in a blow mold repair shop. The inspection was done by a compliance officer, and you can see his name there. Just the background here, of course, to have an OSHA inspection, it can occur for different reasons, but in this case, there was a complaint initiated by an employee, and the employee alleged three things. The employees were overexposed to beryllium while working on beryllium copper alloys, that there was no local exhaust ventilation, and that employees were not trained on the health hazards of beryllium. So the compliance officer went out to the site and did an inspection because of that complaint. Just a little bit of information about the company. It's a small business, been in business for like 8 years. Only had 3 employees at this particular location. The shop information you can kind of picture is a typical machine shop type equipment. Has drill presses, mills, welding tables, finishing tables. 95% of the work they do, they are servicing these old molds. They're repairing them, getting them working again, so that the manufacturer can use them to, like create like plastic containers. But they're doing the service work, and they may also 5% of the time they're building new molds. So the process description, what do the employees do? They weld on the beryllium copper metals, which are part of the mold. These welding rods contain 2% beryllium. The molds are then used by companies which are doing, plastic injection. They're using plastic injection units for containers, and they're high heat and contact areas for beryllium copper. The controls that the employer has in place, they have a welding table, which is really just a kitchen type range hood, and I'll show you a picture of that. They also have a finishing table with no local exhaust ventilation, and employees do have respirators, and they do use a welding hood. This is the range hood that they use. That's their local exhaust ventilation when they do welding. Just a picture here of the beryllium copper contact points. These molds, it's 5% is a beryllium copper component and the rest is aluminum. You can see the copper colored material there. That's where the beryllium copper component is located. The beryllium copper components are 2% beryllium and 98% copper. So it's mostly beryllium, or excuse me, mostly copper, but a little bit of beryllium in there as well. The OSHA compliance officer decided to do air sampling and wipe sampling. So these are some of the methods that they used. You can see here a picture of a person using a Dremel who's working on repairing one of the molds. And you can see how he's using that, wearing a respirator. You can also see the air sampling device in the background there in his breathing zone. Here's a picture of the welder set up with air sampling. You can see again, the cassettes, and in this case, they actually did air sampling inside the hood and outside the hood. And there you can see the welder at work. Obviously, he's working under that kitchen hood. Not really effective local exhaust ventilation because it doesn't, it pulls, the air is just going to move that, that fume, possibly right up through his breathing zone. Their results that you can see that the air sample results were they are here. The 8-hour time weighted average were actually below the permissible exposure limit, both now and at that time. However, the sealing sample results, the short-term sample results, the 15-minute averages that were collected, you can see on the welder, it was 5.6 micrograms per cubic meter. Compare that to a limit of 2.0. And on the finisher, it was 2.6, and compare that to a 2.0. Of course, both of those sealing sample results exceeded the OSHA permissible exposure limit. There were also wipe sample results obtained. At the welding table, you can see the different levels of beryllium, 0.48, Dremel table 2.41, general workbench 1.11, microtape wipe table 0.153, and the watercolor was actually 0. So what are the findings from this inspection, from this investigation performed by OSHA? And you have different things. Not only did you have beryllium overexposures in this case over the short-term exposure limit, the 15-minute average, you also have other things that were cited here. You have violations of in the welding standard, the requirement to have beryllium-based, to have local exhaust ventilation when you're using beryllium-based filler metals. They didn't have a proper respiratory protection program. They didn't have a written program. They didn't have Appendix D provided to employees. They weren't doing medical evaluation. They weren't doing fit testing. These are all violations of the respiratory protection standard. There was also some violations of the hazard communication standard, 1910.1200. They didn't have a written HAZCOM program. There were no safety data sheets available. They hadn't provided training to employees. And there were even housekeeping violations, the sanitation standard. You have housekeeping and you have a consumption of food, beverages around what are considered toxic materials. And there were also violations that weren't really even industrial hygiene related. There was a fan guarding issue found. There was an electrical issue found, guarding of live parts, and use of compressed air. So you can see during this inspection, the initial inspection was because of beryllium. but at the end of the day, there was multiple different violations found covering many different standards. And you have to keep in mind that, you know, you probably have many different standards that apply in the workplace for any occupational environment. So the employer did take abatement actions. They discontinued the process until abatement could be done. They placed an emphasis on hand, arm, and face washing. They provided full personal protective equipment and laundering. They gave the employees, put them in a medical surveillance program, which included the BE LPT testing. They gave them continuous flow airline respirators and installed local exhaust ventilation. Here's an example of the local exhaust ventilation. They also made a pretty important process change where they switched to a welding rod that contained no beryllium. And that was really the thing that really helped the most. And you can see that they then did some follow-up sampling. The initial samples back in March 01, you know, exceeded the OSHA limit. And then if you take the last set of samples after they changed the welding wire to contain no beryllium, they actually had beryllium exposures that were below the limit of detection. So that's really the end of the webinar for beryllium. I hope that was useful information to you. I just want to put in, you know, I mentioned during the OSHA inspection that there were really many types of OSHA standards that could apply to your workplace. And if this is, if you have concern about OSHA, you know, are you properly protecting employees? Do you have OSHA standards that need reviewed? Do you want to have an OSHA inspection, a consultation at your facility? Please contact us. We're part of the Pennsylvania OSHA consultation program. There's no fee for us to make a visit and help you with these things. If you're interested in having a consultation done, all you need to do is go to our website, which is listed there, and put in a request consultation, and it'll ask you for some real basic information, and you fill that out, submit it, and then we will contact you and set up that visit. So again, we're happy to help you with that. I hope you find this information of this webinar useful. Appreciate your time and attention. If you need to reach me, I can be reached. You can call the office there, they can get me, or you can just email me at the email address there, dlarson, DLARSON @iup.edu. Again, I'm listing here the IUP websites. We're also on Facebook, and we're also on Twitter. Thank you very much for attending the webinar today. I do appreciate your time and attention. There is an upcoming webinar called The Common but Often Unrecognized Electrical Hazards in the Workplace, and stay tuned for details on that. So again, I hope you all have a fantastic day. Thanks again for your time and attention, and we'll see you at the next webinar.